Hi, everybody. Welcome to our webinar on building fast, scalable app monitoring with open source. My name is Robert Hodges. I'm CEO of Altinity, and I'm joined today by Roman Khavronenko from VictoriaMetrics. We are going to be doing this webinar today, taking about an hour to walk through different approaches in building monitoring systems using different types of databases. Before we jump in and let Roman start with the actual content, I'd like to tell you just a couple of things which will help you enjoy this webinar more. One is that we are recording it, and for everybody who's signed up, we will send you a link to the recording as well as the slides for this webinar. You'll get those probably within about 24 hours after the webinar is done. So you don't have to take frantic notes. It's all going to come to you through email. The second thing is that we have a couple of ways that you can answer questions or pose questions. You can stick them in the question and answer box, which is provided by Zoom. We'll answer them as we have time, and you can also stick them in the chat. So don't be shy, just whatever is convenient, toss them in and we will we'll answer them. With that, let me just introduce myself and then I'll turn it over to Roman. So I'm Robert Hodges again. My background, I'm a database geek. I've been working on databases since 1983. And my day job is I'm CEO of Altinity, but I still do a lot of work with databases, including webinars like this one. So Roman, over to you.
Yeah, hello everyone. My name is Roman Khavronenko. I'm a distributed systems engineer, and I'm also a big fan of monitoring and observability topics. And also I'm an engineer and co-founder of VictoriaMetrics TSDB and monitoring solution. And I welcome everyone on this webinar, and I hope you will find it useful. So let's begin with what is actually application monitoring. So before that, we need to answer the question, why would someone need a monitoring? So let's imagine a situation that you are running a service, user-facing service, and out of sudden, your users started to receive the errors. And you ask yourself, why? Then you go for more specific questions like when they started to receive those errors, or how many actually users receiving those errors, or how many errors is there? Like maybe it's only one error, or maybe which region or country was affected. And when you have answers to those questions, it is really helpful to find the culprit of the issue and fix it as fast as possible. Okay, so for me, it is no doubt that monitoring is a super useful thing. And if you want to run something reliable, stable, and predictable, you need to have a monitoring. So what it takes to have monitoring, how to make it work? Well, basically for this, you need only three things. The first one is the question, is the right question to ask. For example, like, in which country my users are getting errors, or how exactly many errors they are getting. That's the question. The second thing is the information which contains the answer to your question. Because, for example, if you don't have any information about users per country or per region, you can't answer the question, or can't answer the question at which regions they are getting errors, right? And the third thing is the respondent. That's something which can access this information and answer to your questions. Okay, systematically, it looks like this. In the middle, you have some blue thing, which accepts whys from you. It gets access to information, does some processing, and provides you a response. If you want a metaphor, it is something like a mysterious wizard, which has access to the wisdom, and it can answer, it knows, this wizard knows everything, but he will respond to you only if you get the correct answer to ask. And there are actually many wizards out there, and you as a hero, before you begin your journey, you need to pick wisely which wizard will help you in your journey, because there are too young wizards, or maybe too old wizards, or some wizards could be even too pricey for continue your journey with them. But there is always a just right wizard which will help you in your specific case. So, and if you found your wizard, choose it wisely. It will provide you correct answers to your questions, answers which would help you to reach your goal in building stable and reliable applications and systems. Okay, let's get back to reality from the metaphors. So the blue thing in the middle is actually TSDB, which stands for time series database. Time series databases are usually used by monitoring systems. And these monitoring systems usually has their ways to collect metrics, put them into time series database for processing, and then they have query API or interface where you as an actor or as a hero can ask your questions and get meaningful responses. Okay, in these sections, I will provide more information about VictoriaMetrics, and maybe at some point it will become your wizard in your journey. So what is VictoriaMetrics? VictoriaMetrics is an open source time series database and monitoring solution. It can vertically and horizontally scale. It means you can build a large cluster of VictoriaMetrics to process hundreds of millions of data points per second. It is also really simple to operate because we put a lot of work to make it simple to run. It is cost efficient. It is Prometheus compatible, which makes it really useful to operate with all the tools which are compatible with Prometheus as well. And it is open source. It is free forever, and there are no implications for you to start using it right now. Okay, when to use VictoriaMetrics? Well, basically, our users mostly use it for Kubernetes monitoring, for hardware or infrastructure monitoring, for APM, IoT, edge computing, alerting, anything which has relation to metrics, actually. And as I said, VictoriaMetrics is a monitoring solution, which means it has a built-in TSDB in the middle. It has a user interface, query interface for you to ask questions and get responses. And it also has its way for metrics collection. It can collect metrics via pull model from your application or infrastructure, or it can accept metrics from your applications via push model. Okay, but what is actually a metric in this scheme? So metric is some numeric measure or observation of something. For example, like number of served requests, or number of received errors, or request latency, or CPU usage of my laptop, or maybe a number of participants in this webinar is also a metric. And when you have these metrics, you can then ask specific questions like, what was the total number of participants during this 1 hour of the webinar? And it is a useful information. Okay, metric structure is also really simple. So metric consists of metric name. And metric name is something for humans to read, for humans to understand. And it contains a meaning. So when I read request total, I can understand that probably this metric measures the number of served requests. And to better understand what this metric does, there is a meta information which adds even more context to it. So I can say that we serve a request with status code 200 and request with status code 403. And then value shows us how many requests we serve with these codes. So I can say that we served 10 requests with status code 200. And then you have a timestamp. That's a specific moment of time when this observation was taken and was true. Okay, so how we store this metrics. You see the example on the screen, and it contains various metrics. Some of them are with meta information, with labels, and some of them contains no meta information, but they are all different. And in the same time, VictoriaMetrics inside in the data model is schemaless. There is no notion of schema, no notion of table, no notion of database. It basically stores everything you put in it. So our user is free to update metrics whenever he or she wants. That also means that update or change metrics is very simple, because you need to make a change only in your application, and you don't need to apply any changes to your database, to your TSDB. You don't need to keep backward compatibility or anything else. So it's really simplify the things. Okay, and how we store these metrics. So if we check this metric structure from the previous slide, we can convert it to something like a samples table on this slide. And despite the fact that VictoriaMetrics doesn't have a notion of a table or database or something like that, we still benefit from the columnar approach for storing data. So basically, we store value, timestamp, series ID in a separate columns. And we can benefit from this columnar approach because we can apply different processing techniques for these columns. We also have different compression codecs for these columns. So timestamp can be compressed with double delta encoding, and value can be compressed with modified Gorilla compression algorithm, which provides a lot of benefits. If you want to get more details about how VictoriaMetrics is designed and what principles and how it is similar, which ideas, architectural ideas it shares with ClickHouse, please check the talk which our CTO gave at OSACon 2021, where he shared a lot of insights about internals of VictoriaMetrics, and also some ideas that he used in VictoriaMetrics were then also used by ClickHouse. So I really like this collaboration. And all these technical details helps VictoriaMetrics to be efficient. So for example, the compression ratio reaches 0.4 bytes per sample. Ingestion speed is around 300,000 samples per second per CPU core. And the scanning speed is also astonishing. It's like 50 million samples per CPU core. Along with clustering and horizontal scalability, it gives you basically infinite storage for time series processing. Okay, and a few words about metrics collection approaches. So one of the approaches VictoriaMetrics inherited from Prometheus called pull model. With this approach, monitoring system or VictoriaMetrics collects metrics from application on its own. So application doesn't know about monitoring system existence. Only monitoring system knows what it needs to monitor. So once per interval, it goes to the application and collects metrics from that. This approach is very useful and is very robust, but VictoriaMetrics also support push model. That's a more classic approach to deliver metrics, where application decides when it wants and at which volume to deliver metrics to the monitoring system. And for the push model, we actually support a lot of the ingestion protocols. So we have integration with Prometheus Remote Write API. We have Datadog integration, InfluxDB, Graphite. You also can push data in JSON or CSV if it would help to keep your application simple for metrics delivering. And a third part of monitoring system is a query API. So VictoriaMetrics doesn't support SQL language. It supports its own query language called MetricsQL. And in recent talk at OSACon 2022, I gave a talk named Specifics of Data Analysis in Time Series Database. And I try to explain in this talk why VictoriaMetrics doesn't support SQL, or why SQL isn't a best choice for time series data. So if you are interested, please feel free to check it. Maybe you find it useful. But still, I want to give some examples about how MetricSQL works. So you see 3 examples of getting data back from the VictoriaMetrics. The first query just requests all the metrics with the name request total, and we get 2 time series in response. The second query requests only those time series which has status code 200. So yeah, you just as easy as is, you specify code in curly braces and you filter your results. And the third query does an aggregation. It summarizes all time series with name request total and groups them by label path. So as simple as is. Okay, demo time. So in the demo, I will try to show you how to run VictoriaMetrics and how to put some data into it and get it back to plot on the graph. So here I have a folder where I already downloaded VictoriaMetrics binary from the GitHub. You also can have Docker images of VictoriaMetrics, and let's just run it. So we started VictoriaMetrics, and it is working. Now let's try to put some data into it. So I have a really simple script here, which runs in a loop from 1 to 100. And what it does, it actually executes a curl command, which sends in a post request with this payload. And this payload contains a metric with name HTTP request, with meta information of path, like /home. And it sends this data every 5 seconds. Okay, cool. So how we get this data back or just check that it is actually written. So when VictoriaMetrics starts, it says that it started a HTTP server on this address. So let's visit it, and we get a response from the VictoriaMetrics server. And what we are looking here is VMUI, which is web user interface for getting metrics and visualizing them. So we are writing metric called HTTP requests. So let's just type it and execute the query. Okay, and we get a response of our metrics that we are writing. So let's get last 5 minutes instead of last 30 minutes because we just started to write it. And we see our metric which is incremented once every 5 seconds. And yeah, and here we have a legend which shows that we got only one metric in response, HTTP request with our path. And yeah, so we got the metric back, and we can do the right things with that. But actually, this metrics is kind of boring because there is no much sense behind it. It doesn't give you any insights. It just artificially generated metric. So when we started the webinar, I started also collecting metrics from my laptop, metrics like CPU usage or memory usage or network usage. And I'm doing it via open source collector called NodeExporter, which is widely used across many installations and environments around the world. Basically, probably any data center running NodeExporter for collecting metrics. And let's try to see what is my CPU usage during this webinar. So for this, I know that there is a metric called node CPU seconds total. From its name, it's easy to say that it probably contains CPU usage in terms of time spent by CPU for doing work. And if we execute it, we get some lines plotted here. And legend suggests us that there are multiple time series in return. And these time series are different by CPU number. So probably I have 2 CPUs because I run this exporter in the Docker, and Docker thinks it has access only to 2 CPU cores. And also it has a context of mode. So mode shows us in which mode CPU is used. And looking on this graph, we see that most of the lines are flatlined, but only one type of mode is actually climbing up, and it is mode idle, which probably means that my CPU is doing nothing. It is in idle mode. So let's try to filter everything by this mode idle. Okay, and we get these two metrics in response. If we check, it is mode idle for 2 CPU cores. Okay, since this metric shows us a cumulative counter, which only climbs up, to get the per second change of the CPU usage, the one that you are used to see in utilities like htop or activity manager, we need to apply extra function called rate, which calculates per second change of the metric. And with this function, we can now say that we are likely spending like 99% of the time in the idle mode. We can also multiply it by 100 to make it a real percents. So 99% is spent on doing nothing with my CPU. But that's not all. With this open source exporter for metrics, you can get actually much more powerful results, because there are many people who are using this exporter, and they also developed a lot of tools which could be helpful for you. And this is the beauty of open source and compatibility features. So as I said, this exporter is very popular, and if you go to grafana.com dashboards, you can find that dashboard for this specific exporter is the most popular dashboard across all other dashboards, and it has like 22 millions of downloads. So let's check if we can use this dashboard. So I also have downloaded Grafana, and I will just run it right now. And let's see if we can get some useful information from it. So I go to Grafana, which is running default on localhost port 3000, and try to import this dashboard. Okay, it's almost done, and it suggests to select a data source, and I already configured data source to point to my VictoriaMetrics that we launched a few minutes ago, and we import this dashboard, and we see that we get some data. Of course, we don't have 24 hours of data because we only spent 20 minutes on this webinar. So let's get last 15 minutes. And yeah, here's what you get with the power of open source. You have CPU usage, you have memory basic usage, network usage, disk space usage, and a lot of additional metrics and visualizations that you get just for free because of the compatibility and power of open source. I hope this will be useful to start. Okay, and let's get back to presentation. There is one more slide that I wanted to show is frequently asked questions you might have about VictoriaMetrics, and can I monitor my SQL Server, Postgres, or any other thing? Probably yes, because there are many open source exporters for almost every popular software. You can have exporter for ClickHouse, you can have exporter for Redis, you can have exporter for Nginx, and you will find alerting rules for them, Grafana dashboards, a lot of recommendations how to use them. So yeah, they are all free and all available in the internet. Another question, can I monitor my applications? Of course, you can. There are also a lot of instrumentation libraries which you can use with different programming languages and to instrument your application to expose any metrics you want. How expensive monitoring is? Well, I did a napkin math for collecting metrics from 100 instances. Each instance emits about 1,000 metrics every 30 seconds. And for that, we will need like 100, and these metrics need to be stored for 1 year. And to store this for 1 year, to collect all these metrics for 1 year, we will need like about 100 gigabyte of disk space, and it will cost us $54 per year. And we also need to rent the S3 Medium AWS instance, which will cost us around $360 per year. So in total, you need to spend like $400 per year for monitoring these 100 instances. So that's the cost efficiency. And the last question, can I run VictoriaMetrics in Kubernetes? Of course, we have Helm charts and Kubernetes operator, and nothing stops you from just launching it with one command. Okay, that was my part, and thank you for listening. I now pass mic to Robert.
All right, thank you very much. Let me try the, there's a question here in the Q&A box. How does VictoriaMetrics protect itself from metrics that introduce extreme cardinality labels? And I'm going to work on bringing up my slides while you answer that.
Okay, yeah, that's a really good question because it's really big problems in monitoring, and it's called cardinality explosion. And for that, we have a protection on our collecting agents, which can limit the number of unique time series per time window per hour or per day. And when this limit is reached, these collecting agents start to reject these metrics. We internally use Bloom filters to register new time series over time periods. And this helps us to protect the main database from these cardinality explosions. So there are handles, there are limits you can apply to your clients, and it will protect you from this kind of issue.
Great. If there are more questions, feel free to put them in the Q&A box as well as the chat. I believe we're going to have some time. In fact, I'm sure we'll have some time at the end and we can cover them. What I'm going to do now is I'm going to talk about using ClickHouse for building monitoring systems. So Roman, can you just confirm you can see my screen okay?
Yeah, I do.
Great. Okay, let's dive in. So ClickHouse, it's not a time series database. What is it? It's a real-time analytic database. And what that means is it's designed to, well, we'll go into the architecture a little bit. It's designed to get very, very fast responses on very large amounts of data. Some key characteristics. First of all, it understands SQL. So it's coming from, sort of a different database tradition from time series databases. But like VictoriaMetrics, it is open source. In the case of ClickHouse, it's Apache 2.0. It's a general purpose database. So it handles many use cases, everything from valuing financials to driving security, monitoring systems to log management. But it also happens to handle time series data very well because most of these large, in fact, almost all large data sets tend to be time ordered in some way. And in fact, for many of them, time is the most important property. So as a result, it's quite useful for building monitoring systems along with all these other use cases. Let me just talk about a few of the characteristics of ClickHouse that make it useful for quick response on large data sets. So there's three things that I think are interesting to mention. First of all, ClickHouse, like virtually all other high performance analytic databases, uses column storage. So it's highly compressed. If you look at a table, all the data is for each column is stored in a single set of files. They are highly compressed, and the table itself is indexed in various ways. There's a primary key index, which can allow you to recognize and locate certain parts quickly, but it also has skip indexes. And in fact, there are even inverted indexes have just been added and are now available. So this highly compressed columnar storage reduces I/O and makes it possible to scan enormous amounts of data with relatively low amounts of resources. The second thing is that when we're querying ClickHouse, ClickHouse is extremely good at parallelizing. So across hosts, this picture here shows 3 tables on 3 different hosts, but it also parallelizes extremely well within a host. So basically, when you run ClickHouse, if you allow it to do so, it will use every core on your on your system. And if, of course, most cores have hardware threads that will use all the threads, it will basically use 100% of the CPU resources. So this allows us to get very, very fast answers to questions by just throwing a lot of hardware at it. And then a final really important part of the architecture is that ClickHouse provides automatic replication between nodes. In fact, sharding and replication are built-in parts of the system, and so it's possible to have data sets that extend to that have multiple replicas for each part of the data set, or each chunk, if you will, and then split the data set into many chunks or shards, extending across, in some cases, hundreds of machines. So that's the basic architecture. Another important thing about ClickHouse is it's very fast to load. Like VictoriaMetrics, in fact, if you look at the performance of things like ingest, speed of query, things like that, it's pretty comparable to VictoriaMetrics. What this means is that ClickHouse can load millions of events per second. So if you have a monitoring system that is, for example, doing things for multiple tenants, in which case you have a huge amount of data, because it's sort of amount of data times customers, or it's a very large monitoring problem, like a large cloud installation or installations, it's very good at ingesting this. We can read from Kafka. You can easily build custom applications to put it in. And ClickHouse is also very good at reading off data lakes. This is a newer capability, but something that people lean on pretty heavily. Typically, when you use ClickHouse, what you're going to do is take that data that you're ingesting and you're just going to put it into what's called an unaggregated table. And by unaggregated, it means we don't do any pre-aggregation of the data. Just every time a record arrives, we store it as a row in the table, and you can query straight off that. In some cases, it is useful because there are questions that you're asking constantly that need a very, very fast answer, or where you want to limit the amount of resources applied to them. It's useful to pre-compute some of the answers. In that case, ClickHouse gives you materialized views. These are basically transformations or triggers, if you will, that get invoked every time a block of data arrives in the source table. You'll run a query across it, and the results of that query will be put in the materialized view table. This is a very flexible feature and allows ClickHouse on very large data sets for predictable questions to give answers in milliseconds. And another key property of ClickHouse that makes it work well for a wide number of use cases, but particularly for monitoring, is it has dozens of input formats. These are just formats that are built in. You'll say insert, and this is a little bit different from conventional SQL, but you'll say insert, give a table name, and then you give a format. And then that name can be any of the following that are shown here. You can read tab separated values in. You can read normal SQL values, which are the tuples that you read in. You can read what's called JSON each row data, and protobuf, Parquet, ORC, you name it. ClickHouse consumes it, and I would say, every month there's probably another format added. It's moving forward very, very quickly. So what this means is almost no matter what the form of data you have, ClickHouse, there's a pretty good chance ClickHouse is just going to be able to read it and stick it in a table, and you can do queries on it. So final thing, ClickHouse, I said, was not a time series data set or database, but because time is so important in these large systems, it has a huge number of functions that allow you to store and manipulate time data. So there are three commonly used types, which can store time. There's date. Obviously, that just gets you to the day. There's date time. That's basically a Unix times or Linux or Unix timestamp. So 1 second precision. And then finally, there's datetime 64, which can go all the way down to a nanosecond. If you're working with Grafana, datetime is probably your friend. That is the one that Grafana and some of the other BI tools are most familiar with. And so if you have a timestamp or other field in the table, it means that that table data is going to be easy to process with those tools. At the same time, there's a huge number of functions that will allow you to manipulate time data in various ways. I'm just giving a couple dozen examples here. For example, you can take any date time value, run it through 2YYYMM, and it will just pop out an integer, which gives you the year and the month. This is very, very useful to be able to quickly transform data. This is something you commonly do in queries when you're bucketing things by month. For example, you would run this to YYYMM. Similar things, normalizing start of year, start of minute, you name it. So there's lots of stuff here, and so almost any operation that you want to do on time, ClickHouse tends to have a way to do it and do it well. So with that background, what I'm going to do is just walk through building a simple host monitoring system. So ClickHouse is general purpose, and so it really means that it can monitor anything. I'm going to go with oh, here's a question coming up. How does one handle changes in the schema? I'm going to get to that in a second. Just hold your breath. So we'll start with just doing something simple. I'm going to, probably everybody on this call is familiar with VMstat. It's a very popular Linux and back in the day Unix utility, and it just pops out stats on your, on your system. But it could be anything. You can regardless of the problem, as long as you can find something to generate the data, you can stuff it into ClickHouse and do fun stuff with it. So what we'll do is we're going to build a little collector, which will run VMstat and pull the data out. We're going to feed it into ClickHouse, and then we're going to build a Grafana dashboard to look at it. So let's do the first step. That's to generate the VMstat data. So if you're a Python fan, this won't look totally frightening, but basically what it's doing is it's opening up a process, a VMstat command, and it's just reading the data out. And as it turns out, I'll translate it for you. It's just turning it into JSON. I don't have to do this. I could, there are simpler formats, but in fact, I wanted to play around with some of the JSON transformations. So we're going to dump it as JSON, and that makes it easy to consume. What does it look like? Well, when it goes through those, 13 lines or so of Python, what you get is the output in addition to the output from VMstat. I took the liberty of adding a timestamp and a host name, and then everything else is the VMstat variables, named exactly as they appear in the header line. So here's 3 of them. So this output is being generated every second in my little app, and the next thing that we need to do is we need a table to store this. So let's design that table. Unlike VictoriaMetrics, ClickHouse is SQL based, and so of course it does have schema, and that means that everything we're going to process has to be in a table. Now those tables can be much more flexible than a conventional SQL table, and I'm going to show you some examples of that in a minute. But for this example, it turns out that ClickHouse can just read that that JSON format I showed you. We call that JSON each row format, and it can just stuff it straight into the columns of a table as long as those columns match the JSON. And so I've designed exactly this table, and the first 3 things that we see here are actually what we call dimensions. So these are things that characterize the data, and then everything else in the table is measurements, kind of like the metrics that Roman just talked about a few minutes ago. And so we also, when we're building these tables, we do a few things that are a little bit different from SQL. If you haven't used ClickHouse before, we have an engine called MergeTree. That's a storage engine that is designed for very large tables. We partition the data, which tells how to break it up, and then we give an ordering, which also implicitly defines what's called a sparse primary key index that allows us to find sections of data within the table very quickly. So this is the basic format of the table. So we create that table, and now we can go ahead and start loading data into it. So not unlike VictoriaMetrics, it is very, very easy to load data. So to load my JSON data, I'm going to issue a SQL command like this, which is to insert into VMstat, and I'm going to tell it the format is JSON each row. And so ClickHouse is now ready. It's ready basically for a stream of data. I'm going to load this in the simplest possible way in this example, which is that I'm going to stick the data into for this illustration, I'll just stick it in a file, and then I'll load it with curl. And so I'm going to do an HTTP post. ClickHouse has a post interface or a HTTP REST interface. And so I can basically load it up, run my query, and that will pop the data into the table. That's all I have to do. Or if you want to do something a little bit more sophisticated, you can write a Python script. In fact, for my example system, that's what I did, but that script is too long to show you here. And I want to illustrate how simple the inserts can be. There are many other ways of inserting data, but these are two common ones. Fourth thing, now we can build a dashboard. So in this case, I built a little dashboard, and that is the Grafana. As long as you're, sort of handy with it, you can quickly, put together a dashboard on the ClickHouse data, ask any, sort of show any types of things that you want to do. This dashboard here, because I haven't used Grafana for about a year, it took me about 90 minutes to put it together, and we'll show how that works in a minute. If you're using Grafana with ClickHouse, I want to point out that there's actually now a couple of plugins for using Grafana. The most popular one by far is actually what is called currently called the Altinity plugin for ClickHouse. Its name when you look it up is actually VictoriaMetrics, because it was originally developed by Roman, my partner here in this presentation today, when he was working at VictoriaMetrics a few years ago, and when he left, he transferred it over to us, and we've been maintaining it ever since. There's now another Grafana plugin which is offered. It's an in-tree plugin that's maintained by Grafana, and it's also in collaboration with ClickHouse Incorporated. So you can use either one of these. I use the Altinity plugin because it's the one that we maintain and know well. And after loading, then you can kind of go crazy, because one of the other differences between ClickHouse and a system like VictoriaMetrics is that you can also do analytical queries which reach deep into the data and ask arbitrary questions. So for example, if I see something, if I want to ask some questions about, hey, what's the average load on my systems? Do I need to think about upgrading CPUs or machine sizes, as the case may be? I might want to just run queries, across arbitrary portions of the data, do sort of slicing and dicing type operations, and these are pretty easy to do. This query, which is not too complicated, is simply asking the question, in the last 24 hours, which of my hosts had a full minute where they averaged only over 25% load, and then just spit out those host names and the number of minutes that they were over. These are the hosts in my closet. As you can see, they're not very busy hosts. The only reason that they even appeared on this was I was running some performance tests to put interesting data into the metrics. But this is an illustration of how you can now go ahead and begin to add all kinds of sort of analytical type queries where you're exploring the data to understand it better, to make decisions about your business, so on and so forth. So with that, I'd like to show you this in operation very quickly. We'll just sort of go over the parts. And here's our dashboard. But let's first look at what's going on out here. So let's just have a look at the scripts that we're using to collect data. So the data collection script is pretty simple. It's that Python that, sorry, wrong one. It's called vmstat producer. So it is just these lines of code. And in general, writing scripts to collect data tends to be relatively simple, as long as the data is in some easily accessible form, like just run a process, collect information, and spit it out as records of some kind. Similarly, consuming the data is relatively easy. I wrote for this, rather than using the curl command, I actually wrote a script which knows how to read this into, basically take the data, those records from standard in, and loads them up into ClickHouse 10 at a time. This Python is some of the worst I probably have ever written. It could probably be done in half this length, but I was trying to get it to work quickly. So what this does, though, very simply, is it accumulates the lines 10 at a time and up to 10, and then every time it gets 10 of them, it just pumps it into ClickHouse. And these scripts then are run in this simple example. They're just run as follows. This where we have the producer running, and then it just pipes the input to the output over to the consumer, which sticks it in ClickHouse. I basically had this script running for about a day and a half on this computer, or even longer, and that's generating my data. So that's pretty much all the fixings I had to do. I can go and see the data in ClickHouse. I just log in and I can use monitoring, and there's the table. And you can see VMstat, and I could run that query that I showed on the last slide, and we would get an interesting answer out of it. So that's it. Let me just show you just play around with the hosts, or excuse me, with the Grafana dashboard. So Grafana is really handy for operational metrics. It's we were talking about it before the call. It's sometimes a little bit cranky to use, but it's definitely very interesting for being able to recognize, to build operational dashboards that you can then easily manipulate. So for example, this is the data coming off my the base feed from both of them. I'm just tracking the average CPU usage. I can see, for example, that, hey, there were some interesting things going on here. What was this? Well, this was the system called Logos 3 hit 100% CPU utilization at this during this time interval. So what we can do is we can build that out a little bit, and then we can actually go and select Logos 3 and look at the data there, and basically see things like memory usage, see things like CPU, and we can recognize, okay, as it turns out, I was running a performance test using Sysbench, and this drove the CPU to 100%. So Grafana is very flexible. That VMstat data contains a wealth of information. I can also see amounts of sort of the memory, as you see here. There's other types of metrics out there. It's pretty easy just by building simple, going ahead and continuing to add panels to this. I can build up a pretty comprehensive set of metrics for these Linux hosts in no time at all. So that's the demo. Let me go ahead and again, just to be clear, this whole system I set up in something on the order of 90 minutes to 2 hours. It really didn't take very long to do. So let's go back and just polish off ClickHouse. So one interesting question, and this is the question that was asked specifically: how does one handle changes in the schema in the context of time series, new labels, change in label names, etc.? That's a really important question. So and that's exactly what this slide is designed to do. ClickHouse doesn't always have to store everything in a column. I happen to do it that way because it was quick. If your data isn't going to change, that's a good way to do it. But there's at least 4 other ways, and more beyond that you can simulate time series behavior, which allows you to have sort of a pool of data with changing properties. And one of them is to take those blobs, and you can actually just stick them into a column where you store the JSON as a string. And what you can then do is you can materialize out a few of the columns by just pulling them out with functions, sticking them in the header of the table. If you need more information, you go dig into the JSON and get it. That's a little cumbersome, so there are actually some better ways to do this. Another one is to take that JSON value, like the JSON that I showed you, and store it in what's called a map column. And a map column stores key value pairs. So those would be stored in the map, and then you can pull some of them out into regular conventional columns if you like. Otherwise, it's fairly easy to run queries on the map. Still another way to do it is to have what are called paired arrays. And basically, you extract the header values into one of the arrays, and then you have the values the keys into one of the arrays, and the actual values are then in a matching array in the same order, and you can basically run queries on that. And then finally, ClickHouse this year introduced what's called a JSON data type, where you can take those JSON documents and you can just throw them into ClickHouse, and they will then ClickHouse will do its best to parse the format of the JSON and basically assign each key to columns. This one is less well suited to storing very diverse types of data, because you tend to get relatively inefficient storage in that case. As you get more and more if you get JSON, for example, that's arbitrarily nested, or wide variation in the types of keys that you're storing, then this is likely to be less efficient. The effect is, though, that you can simulate many of the capabilities you get in these databases and process this time series data very well. And then more generally, ClickHouse is just a general purpose database, as I said in the beginning. And so it has all kinds of libraries that allow you to do ELT, to do event streaming, rendering display. You can run it on Kubernetes, and there's a bunch of client libraries. So you can build any kind of application you want. And this is where, if you're looking at, sort of just monitoring Prometheus, VictoriaMetrics is a really great choice. If you're looking at building something more custom, for example, doing application performance metrics, where you also want to, combine with other data, for example, join across tables, then perhaps ClickHouse is a better solution. And then there's all this software to help you build it. I'll skip over this, but here's where you can find out more about ClickHouse. Lots of sources here. And it's a very large community and very popular, like VictoriaMetrics, of course. So with that, we're getting to the end of our talk. We just have a couple of other screens. So just some comparisons here, and I think some of these are pretty clear. ClickHouse, you can read this slide, but it talks SQL, stores any kind of data. Anything you put in is just a row in a table. You do use tables. It's very easy to load data with simple clients. You can pull from data from Kafka and object storage. The queries are very versatile, so it's very easy to add, to construct, to answer very complex questions, particularly if you use joins. And then ClickHouse has incredibly strong aggregation capabilities, which are very fast and very powerful. Virtually all open source BI tools can talk to ClickHouse, and it's fast and scalable. Roman, do you want to sing the praises of VictoriaMetrics, things that you want to highlight about what it can do?
Yeah, sure. So in this comparison, VictoriaMetrics is also similar to ClickHouse, only it doesn't talk SQL, but it talks MetricsQL, PromQL, and also we have integration with GraphiteQL, so you can use Graphite query language. VictoriaMetrics is also optimized for storing data, huge volumes of data, but it is specifically time series data. And yes, VictoriaMetrics doesn't have a explicit schema. You don't need to define tables, so you just put the metrics of the structure I mentioned. VictoriaMetrics has integrations with different query languages for application instrument and for collecting metrics of various exporters. VictoriaMetrics can pull data from Prometheus exporters. It has integration with Kafka, and it also supports the direct push of the metrics or of the data, like ClickHouse does. MetricsQL is not that powerful in the meaning of versatility like SQL, but it is much more advanced for time series specific things and functions related for time series data processing. This is correct that we integrate with any BI tool which speaks PromQL. And yes, we're trying to remain extremely fast and scalable. That's
yeah, and I didn't even bother to put like performance numbers down, because you had you mentioned, sort of per core performance, and ClickHouse is pretty comparable depending on what you're doing. So yeah, and one thing I should say is that, like, like what would I choose if I were building a system? Well, both actually. It turns out we run a cloud. Altinity.cloud is our cloud for managed ClickHouse, and we use ClickHouse for the custom parts of the monitoring, and we use VictoriaMetrics to store all our Prometheus data. So we're happy with both, and don't have any plans to change that anytime soon.
Yeah, I would also add that the difference, as I used to explain the difference between ClickHouse and VictoriaMetrics, or ClickHouse and Prometheus, is that VictoriaMetrics or Prometheus-like systems, they are capturing like a snapshot, the state of your application, the state of your hardware at each specific moment of time. When ClickHouse can store events, like when event happens and you record that, and then you can process that. So that's the difference. VictoriaMetrics is for storing and processing the state of the system, and ClickHouse can process actually anything. It can process state, it can process events, and yeah, so it's general purpose database.
Great, and we're here to help. So Roman, do you want to tell about what VictoriaMetrics does for people who want to build these systems?
Yeah, sure. So VictoriaMetrics is mostly open source, like 99% of all the functionality, everything I mentioned here in the talks, except of graphite integration, is open source. You can have single version, you can have cluster version, open source, free commercial use without any limitation. So you can build really large systems using only open source. And then we have enterprise part of VictoriaMetrics, which adds some more security improvements or automation, which usually needed for enterprise companies. And besides that, we also run a managed solution for VictoriaMetrics for those who don't want to bother with setting up something manually. So you just go to the cloud, and in a couple of clicks, you get ready VictoriaMetrics cluster or binary ready to accept your metrics and visualize them. Yeah, so that's mostly it.
We have a pretty similar business model. So we're layered on top of ClickHouse, which is open source. Everything we do that is things like the Kubernetes operator for ClickHouse, stable builds for ClickHouse, which are ClickHouse builds that have 3 years of support and are certified for production use. It's all open source. We run a cloud platform for ClickHouse. We can run it both in our VPCs if you want just an endpoint and get started right away, or if you have a Kubernetes cluster, or just give us access to your account on Amazon, for example, we can just set it up and run it there in your own account. We offer enterprise support for ClickHouse that's baked into the cloud offerings, and we also have a bunch of on-prem or self-managed customers, and then we do education for ClickHouse. So I hope you'll visit both. Check out both of these. These are great solutions. With that, thank you very much. Here's contact information. Just come to our website so you can get hold of us very easily. There is a question here. We'll hang around and answer questions for a bit. There's a case where in a case where one uses ClickHouse to store metrics, logs, traces, is there an ergonomic way for data correlation? Okay, by ergonomic, I take it you mean something that's easy to do and doesn't involve like massive distributed joins. One thing that I'll just throw out there is, depending on what you're storing for the systems, a really common way to handle them in ClickHouse is just to stick them all in one table. So you can have log information, like log messages, can coexist with data from metrics data from monitoring. There's nothing that stops you from doing that. And ClickHouse has a number of features that allow you then to correlate this data basically through aggregation functions of various kinds. In fact, I have a talk on how to do this. This is called the big table model. ClickHouse has, in addition to very powerful aggregation functions, some of those functions allow you to just do this in a single scan. So this is something ClickHouse is very big on, is not having to scan the data multiple times, not having to do self joins, things like that, because they're slow, and you don't get you don't get results back as quickly as possible. Depending on what else you're storing, reference tables, those types of things tend to be separate tables, and you join on them. Beyond that, you'd have to look at the specific use case. If you have something that's really enormous, that simply won't fit on single machines or single tables, then you'll have to consider some kind of bucketing, perhaps by tenant or something like that, that allows you to keep the data for single tenants in a single shard, and then you can easily get to it. Question here, is the webinar recorded? Absolutely, it is, and we will be sending a copy of this afterwards. Roman, we're at time, so at this point, I think we can stick around for another minute or two. If there are other questions, we'd be happy to answer them. In the meantime, Roman, thank you for a great presentation. I learned a bunch about VictoriaMetrics that I didn't know before we did this talk.
Yeah, and thank you for the opportunity to participate. And it would be a pleasure to continue such webinars if we want to dig in more details how to build a good monitoring solution. Because in this webinar, we discussed only like basic principles, at least from my side.
Absolutely. Yeah, there's so much more about this subject. If you want to hear more, contact us, let us know. We'll figure out a way to present it. Our goal here is to educate. And beyond that, just get out and try this stuff. Try both systems. They're great. And we'll, and see how it works, tell the community how it works for you, and contact us for help. So with that, I think we'll call it a day. Thanks again, Roman. Thanks again to everyone who attended. It's a pleasure doing these talks, and stay tuned for more, and we'll talk to you soon.